So hi everyone, it's great to be here. It's my second time actually speaking at API Days, so I'm really happy to be back. So today we are gonna talk about subscription webhooks. So in general about how webhooks work and how we can use GraphQL in order to improve them and customize payloads that we send between our services. So my name is Marcin Gębala. I'm principal developer at Sailor Commerce, which is a startup based in Poland, where I'm leading the backend team that builds the GraphQL API at Sailor. And I'm using Python and Django, and I've been working on this API for the last 4 years. I'm also one of the GraphQL Wrocław organizers. This is a meetup that we host in Poland. It's currently the biggest GraphQL meetup in Poland. So before I go to webhooks, I want to build some context around how we use GraphQL. And here I want to tell you more about Sailor Commerce. Sailor Commerce is basically the open source GraphQL first headless e-commerce platform. I know there is a lot of buzzwords in here, but it's true, really. So to give you the idea, I'll show you how it looks like. So basically this is a e-commerce software. So it's actually similar to what we've seen in the previous presentation. So in the previous presentation we heard about, I think it was Commerce Layer, if I'm correct? Right. And Sailor Commerce does basically the same thing. I think the only difference is here that this is like entirely open source. So this is a headless e-commerce platform, which means that we provide all of the e-commerce features like product management. We collect checkouts and orders and payments. We allow you to process those orders, process fulfillments in order to track like when the shipments are delivered to your customers. So all of the standard e-commerce features. And we do it in a headless manner, which means that we focus on the API. So instead of providing you the entire like front end, like the storefront, we focus on the API and all the features that we built are in the first place in the API, and then you focus on building your front end yourself, so you have like full freedom in how your front end is built. And as I said, it's all open source, like each component of the platform, except for the cloud solution where we host the platform for you. And what makes Sailor different and what we are focusing on is the extensibility. So in e-commerce, it is very often case that you have a lots of integrations like with different payment gateways, with tax APIs, shipping providers, etc. And every customer has like many different specific use cases. So over the years, we figured out that it doesn't make sense to build all of those features into the core of our platform, because basically we are not able to maintain that over like years. Like we don't know about every payment gateway out there, and we will never be specialists in that. So instead, we rather provide tools so that our platform can be easily extended by our users, and they instead like maintain those payment gateways because they know them the best. And the huge part in this, how we provide this extensibility, are webhooks. So webhooks allow us to communicate between different services. So in our case, Sailor, which is the core part in like the core API part in an e-commerce platform, in an e-commerce store, is one service, and there are another services which we call apps that serve different purposes, such as payment gateways, tax APIs, etc. And if they want to fetch some data from Sailor, they can just use our GraphQL API. And if they want to get notified about events that happen in Sailor, for example, when a new order is placed, they can listen to our webhooks. So we have like two-way communication. That's pretty standard. That's what a lot of systems do on the internet. And in like the traditional approach to webhooks is actually what we started with. So let's have a look at example how webhooks work. In this case, we have an event which is called order created. So this is basically a new order in our store. When this event happens, we send this JSON structure to all the listeners that are registered as webhook listeners. So that's how webhooks work in most cases. You will get this JSON structure, which is predefined and static. So this works. You can integrate with that, but there are some problems with this solution. So, like as I said, the JSON structure is always predefined and fixed for most of the events, and you cannot like control what data you want to get. So it sounds pretty similar to actually the problem that we had in web apps with REST APIs and what GraphQL actually solves, right? So we are wondering if you could actually give this ability to app builders that integrate with Sailor so that they can decide what data they want to get from our backend without using our API, but through webhooks. And why is it bad, like that the predefined structure is, that the traditional approach has this predefined structure? There are a few problems with that. As I said, you cannot decide what data to receive, so you either get too much or too little data. If you get too little data, then you need to make additional API calls, because, for example, for some stuff you just got some database IDs or like API IDs and you want to display more data about this, then you need to fetch this with additional API calls. Also, in our case, where we had the GraphQL API on one side, we also had to maintain this additional serialization layer which generates those payloads. So it's just a maintenance cost. And here comes the GraphQL to the rescue. And let's see how we can solve this. So this is, we came with this idea of using GraphQL subscriptions. So in GraphQL, subscriptions are a way to represent real-time events. And like this example shows how you can instead like define the event for this order created event and to define what data you would like to get. So let's take a closer look at this example. So we use the subscription syntax in here, and inside we have the event field, and inside there is this fragment which is called order created. So that's our event definition. Inside of that we have fields that we want to get for this particular webhook. So in this case this will be the order, and let's say we want to display a simple notification which will tell what's the order number and, for example, what's the user email. And this is how the GraphQL schema looks like for this, this implementation that we use. So on the left we have the event interface. So that's the GraphQL interface that shares some common stuff between each event, such as date of issue, version of Sailor that was triggering this event, information about the user that triggered this particular action, and information about the app that listens to that event. And on the right, there is the schema for this specific event that we saw on the previous slide. So we have the type called order created, which implements the event interface that's on the left. So inside of this type, we will get all of the fields plus extra data that is specific to this event. In our case, this is the order. An order is just the type from our GraphQL schema that we use in our main GraphQL API. So as a result, if we provided this subscription to our webhook system, we would get this example response that's on the right. Let's have a look at how we can create those new webhooks in the system. So we have this mutation called webhook create, where we provide name of the webhook. We provide some target URL, so this is where the payloads would be delivered. And inside we provide the subscription query. So don't get me wrong, we are not running subscriptions with WebSockets. We just use the subscription syntax in order to define the payload. And we just pass this payload inside this query. We save this in the database, and whenever there is a new webhook triggered from our system, we look at this query and we basically run it against our schema, the same schema that powers the GraphQL API, which powers our frontend. And what are the benefits of this approach? Like, we get all of the benefits that are given by GraphQL, first of all. So less data transferred. We are only getting data that we need. I know it may not matter that much in the backend between like backend services communication. It matters a lot when you are sending data to browser, but still, if we are like providing too much data in the JSON payload, the data needs to be somehow generated. Like it needs to go to the database, fetch this data, and it may perform too much database queries. And in this case, you are like getting only the data that you need. So it's in general more like it has better performance generating this structure. Second thing is that we reuse the same GraphQL schema that's available in our API. So any developer that uses our GraphQL API is also familiar with like building webhooks because it's basically the same schema. So we don't have to rebuild like all of those resolvers. Or as I said, we were maintaining like this entire level of serializations that was like generating those payloads for us. Now we just maintain the schema and it generates all of those things in one place. Another thing is that we are reusing data loaders in here. So before this solution, we had to manually optimize each field in the payload to make sure that it's not making too much database queries. And in here, we just reuse the API schema with all the data loaders, so it's just well optimized since the beginning. And then you have all the like nice features that GraphQL provides you, like deprecation directives. So with this approach, we can actually mark a field as deprecated inside our payload. It's something that it's not so easily done in traditional webhooks. When you have an integration that is already consuming your webhook, you cannot just remove a field from this payload because you would break those integration. In here, we can just deprecate a field to let like other people know that it will be removed soon, so they can migrate to some like newer fields. And we have the auto completion, which is very nice and allows you to easily build those webhooks in a pleasant way. And here is the example of Slack app that we have. You can find it on GitHub. It's just example use case of using those subscription payloads. We have this little Slack application that renders a notification about new orders in our system. And on the right, you can see the GraphQL query that is used to render this notification on the left. If you are curious, you can have a look at this link. This is a Next.js app that's that's listening to those webhooks. But I think it will be the most interesting if I showed you actually how it works. So let's see. All right, so this is my local instance of Sailor. And let's go to the products catalog. Or maybe let's have a look at webhooks. So actually the feature that I'm presenting is pretty new and we don't have like full UI for this yet, so parts of the demo will be in Playground. That's the GraphQL Explorer. Actually we are using the new one, 2.0. It's really nice. It has some bugs, but it looks amazing. So let me. Yeah, so this is the query that we use to fetch webhooks that are defined in the system. And at the moment I have two webhooks. One is product updated and the other one is order created. For this, I don't have any subscription query defined. And here there is some query that says what data to fetch. So let's look at the first example. If I trigger the webhook now without this query, it would run the old engine which just generates this huge payload. So let's see how it works. So if I made some changes here and save it. By the way, I'm using this little site which is called webhook.site. It's really nice for testing webhooks. If you are like needing something like this, I really recommend that. Basically, you can generate a URL and use it to receive any JSON. So I just got the webhook. It's called product updated. And as you can see, here is the entire JSON structure that I'm getting by default. And let's say that I just want to listen to some of the fields, like I don't need all of those data. So what would I do? In my playground, I can use it to build the subscription. So as you saw on the example, we have the event field, and here we use fragments, basically, to see like all of the events that we have use the same event interface. So if I use this fragment syntax, I can see all of the events that are in my system. But I wanted to listen to product updated. And inside, I can ask for the product and all of the fields that are available for a product. So let's say I want to get the ID, name of the product, and maybe the description. So as I said, I cannot run this because it's not actually using WebSockets. It's not this thing. We are just using this syntax. So I need to use this little tool to just make it single line. Sorry for that. As I said, we don't have any UI for this yet. It's just purely in the API. And now, I've prepared the webhook update mutation, and here I'll paste the subscription query that we just defined. If I run this mutation, it's saved. And now, let's clear this, and let's run the update again. For example, I don't know, let's make this bold and save this. And I just received a new webhook. And as you can see, I'm getting only those fields that were defined in the subscription. So that's basically it. It shows you how you can control this part of your integrations. So let's get back to the slides. So what's next? We are planning to extend that even more. That's a screenshot from like yesterday because the team is working just right now on this. We are planning to embed the GraphQL Explorer into the dashboard so that you can just run those queries inside the dashboard, save them, and that's it. So you don't have to like do it like as I did manually in the Explorer. Also, we are planning to add the dry run mode, which will allow you to test those subscriptions right from the dashboard to see those payloads, see what data you will get, and also to add a mode where you just run those subscriptions, those webhooks manually. Basically, that's it. As I said, all we do is open source. If you want to have a look at like how the entire e-commerce engine is implemented, you can scan this, and this links to GitHub where all of our tools are available. You can also check sailor.io where like that's the website of our e-commerce. So yeah, lastly, I want to show you like this little advertisement because I'm a GraphQL Wrocław organizer, and as I said, this is the biggest GraphQL event in Poland. So if you have ever chance to or you ever wanted to come to Poland, I really invite you. Or you want to speak, we are like always open. We do the event like every 3 months. Yeah, we had really amazing guests, and some of them are like speaking today even. So that's it. I'm happy to answer any questions. Yeah. Yeah, the request is sent from the server, yeah.
How do you separate that for access control to be sure that someone doesn't access something they're not supposed to?
Yeah. They can be, those webhooks can be encrypted actually, and there are like, you can create a token like this one. I don't know if that's what you're asking, but there are tokens like JWT tokens basically that let you like secure the webhook.
What prevents me from asking data I'm not supposed to?
Okay. Yeah, that's a good question. We have a permission system built in here. Basically, this webhook that I'm testing has access to all data, but you can limit it to only some like selected parts of the application. So by default, you won't have access to anything. You need to, whenever you register a new listener of your webhooks, you need to give them some permissions to some areas of the e-commerce that you wanna like them to be able to work with. For example, those, because like those apps, webhooks are just one thing. This entire configuration panel allows you to create those apps that, like I was showing on this example. These are the integrations that listen to anything that happens in your system. But as I said, it's a two-way communication. They can listen to data, but they can also trigger mutations in our system. They can modify data in Sailor. So for example, your app that you have next to our e-commerce could create new products or update them or create new orders even. And that's all based on those permissions. For example, this permission handle checkouts allows you to create new checkouts, new orders in our system externally from completely different service without using like our front end. Yeah. Any other questions? All right. Thank you so much. Oh, there was actually, yeah.
Sorry, I was just wondering how does Webhooks scale, like, and how much data can you send through?
I don't know if I have this information. We run on AWS, and entire webhook system is running on Celery. I don't know. It's a worker that we use in Python to just run async tasks, and I don't remember the numbers, but we can just scale the worker, like you know, to meet the expectations like of the current traffic. We are running this in production for few big customers, and we never had like performance issue with this. Like those webhook tasks are really lightweight, I would say.